Hello and welcome to this session of Edgecam. In this session, the interoperability of Edgecam and Autodesk's Inventor is going to be reviewed. The strategic partnership between Edgecam and Inventor has existed since the inception of Inventor. The native Inventor model is launched directly into Edgecam. This is a direct load of the solid. It is not a translator. The Inventor kernel is licensed by Edgecam. This advantage of licensing the native file eliminates the failures of translators. The design intent of the solid is captured via the automatic feature recognition, which identifies the manufacturing features. These intelligent features carry the design knowledge directly from Inventor. This information then drives your machining decisions. The part has been loaded in a dual spindle, dual turret lathe. Which machine is not important, for Edgecam post-processors are the most robust and easily developed in the industry. An interactive process has been launched. This process will step through the decisions that were set by the manufacturing engineer who knows the machine best. This process will launch defined machining strategies using an intelligent manufacturing feature which are directly driven from the design. As you can see, the manufacturing instructions are generated quite quickly, but more importantly, consistently, which translates into higher quality programs, reduced setups, improved throughput through the entire shop. Standardization is achieved by consistent tooling selection, speeds and feeds driven by the tool and the material, coordination of the spindle and turret timing, machine movements driven by the current part geometry, including any rapid and feed moves. Cycle optimization comes from the intelligence of the engineer using the power and the control of Edgecam. The in-process stock improves the cycle time by optimizing the tool cutting movements and only cutting the area that is required. Edgecam's control of the tool path allows you to get your part done in your machine the way you want it. The simulation takes it full circle, from the design model in Inventor through Edgecam applying the tool paths, showing the machine and the part progression through the manufacturing process. This allows confirmation of the tools, the process, and the machine movements prior to reaching the floor. Any improvements or optimizations can be made quickly and easily. Did you notice the lower turret indexing to a safe position prior to the B-axis head cutting? What about the parking of the turrets before the subspindle approaches? All of these types of safe moves can be added to your process, reducing costly collisions. Let's go through the data that is available and how Edgecam can leverage it to improve your manufacturing solutions. An example of this type of knowledge-based machining would be as follows. Take, for example, the OD boss on this part. Depending on the current stock condition, the part may require a roughing pass. The system knows the current stock condition. The tool selection is defined by the geometry that is going to be cut. The tool orientation is defined where the part is in the machine. The depth of cut, speeds and feeds are selected by the tool, the material, and the type of machining to be done. Edgecam knows all of this plus more and puts it into an easy-use system that can be driven to achieve your results. And remember, the real cool thing? It's all driven from the original design model. So you are driving your machining from the design model that your customer has provided. Now, a quick review. From Inventor, the native file was loaded into Edgecam. No translators. Because translators don't add value, they actually cost. The intelligent manufacturing features were found. The part was placed in the machine of your choice. A complete machine process was applied, which adapted to the current part. The tools, the cycles, the speeds, the feeds were chosen based on the local manufacturing requirement. Simulation confirmed the proper tool selection and tool path. Now back in Inventor to see how the interoperability works. The part has been revised to include enhancements. Notice the bolt hole pattern changes from 3 to 5. There are other changes in the profile as well. We'll save the part in Inventor and switch to Edgecam, which recognizes that the file has changed and the revision has been made. The user is prompted to accept or reject these changes. The automatic feature find dynamically reviews the part and compares it to the original and identifies any changes. Once the changes have been acknowledged, Edgecam automatically updates the toolpath to the new changes. Simulation is now launched to confirm the toolpath and the new part enhancements. The process that has driven these toolpaths was Edgecam's knowledge-based machining, called Strategy Manager. Strategy Manager allows the automation of Edgecam in a fast and friendly atmosphere, most like a flowchart application. The manufacturing commands are easily captured from Edgecam by a copy and paste method. Then the decisions are added as required based on the triggers that define your process. And now a true product of a CAM system is the good, clean G-code that will drive the machine to produce a good part the first time. Edgecam makes it easy to configure your post-processor to match your G-code requirements every time. Thank you for your time, and please visit us at edgecam.com for more information.